Let's take a look at how the history stack works for modeling in Softimage. Let's get a primitive Polygon mesh sphere. The first thing we get is the property editor for this primitive, where we can modify the radius, the subdivisions, and the start and ending angles of the model. If I close the property page, I can access it again through the Explorer. So in Explorer, click S for scene, E for the selected object. Now we can expand to Polygon Mesh and click on Geometry. And it'll bring back our property page. So here we can continue to modify the geometry. Alright, let's start working on some modeling. Every time I modify a component, it's recorded in what is called the history stack. Click on the M key on your keyboard and we can freely move some points. Get to your Explorer again and take a look at the object stack. Under Polygon Mesh, you can see a component is added each time we move any point in the object. If you keep moving components, a list will appear in the stack. If your next operator is different, it will go up the stack and have a new entry. In this case, the delete component operator. Now if we modify the component, another operator on top of the deleted component. With the move and the proportional, we can continue to modify. So this builds our history stack. Every time we modify an operator, it's added to this stack. That means I can return to any operator at any time in the stack, modify it, and then continue back where I was. So for example, I can go back and erase my delete operator to recover my polygon, and the operators before and after are kept in the history stack. I can even go back to my original geometry, add subdivisions to the model, and it will update down the history stack. Under Edit, we have the Freeze M tool. Freeze M means freeze modeling. If we click this, it means every operator in the modeling stack will be frozen. This enables us to have deformation operators and animation operators on top of the modeling. We can freeze our object, and the operators on top of the modeling operators won't be affected. So select the object and click Freeze M. And all the operators are gone, but the model is still modified. As you can see, I cannot return to the model's geometry page. Even if I hit Enter, the property page will only have its name and its subdivision type. And if I keep modifying the object, the stack will continue to grow. So we can see more operators being added. I can selectively choose which operators to grab with the Control key, delete them, and we'll see our results. For example, let's select some polygons and delete them. Move some points. Now if we select the delete component operator and freeze it, everything from that operator down will be frozen. A good way to work is to freeze a model up to a certain point that you're happy with. So you can freeze where you know that you don't want to make any more changes, and then just continue working. Let's select some faces and delete them again. We can move some more points. And if I want to recover the deleted faces, select the delete component operator and delete it from the stack. We can then go to freeze modeling and we'll freeze all the operators. Let's do another example. Let's get a primitive, curve, circle. Now hit the M key on your keyboard and we can modify the curve. If you look at the history stack, you can see the number of operators increases as you transform the shape. If we were to select the entire shape and press Freeze M, we will flatten the stack and our list of operators will disappear. If you undo the freeze, you'll restore the stack and you can again modify any of the 9 moves we've made. The history stack is very useful, but imagine for a second that you spend an hour moving parts around your model. The history stack is going to get really big really fast. And the history stack is actually using resources from your computer, in this case, your memory. The more modifications you do, the more memory you're going to use. So after a while, it makes sense to go back and freeze the history stack so you can work more efficiently. If you're using a lot of operators, you might notice the graphic display is a bit sluggish. So after a while, when you're comfortable, don't forget to press Freeze M. There is also another way to work. We can work in an immediate mode. This means all the modifications you make won't register in the memory stack. It's similar to moving points around and having them freeze right after you make the move. Sometimes it can be good to work this way, as it uses less resources from your system. But if you use it frequently, just remember that when you're done, you turn it back off, so you don't get any surprises down the road. If I turn it off, then you'll see my stack is active again. Let's see how we can select different components from our objects. Let's get a primitive, polygon mesh, grid. It may help you to press the G on your keyboard and turn off the background coordinate grid. Now once we have an object selected, we then have the option to select its individual components. In this case, we have our edges, points, or polygons. If we click on Edge, we can now go ahead and select the edges. We can click and drag to select some edges. Points work the same way. Click and drag. The selection works similar to selecting files in the Windows environment. I can use the Control key to toggle and add to my selection. I can add to the selection with Shift. The same with polygons. Everything that goes inside the selection box, you can control to make it toggle. All these selection options have shortcuts. T will enable the point selection tool. U will select polygons. And I selects edges. Now we can also explore a bit of the selection options. So let's go to Modes and click on the scissors to extract this window. And if you look at the windows, you'll see the shortcuts right to the right side. Here they have T for points, E for edges, and Y for polygons. If you press Y for the polygon tool, the selection box you draw must completely surround each polygon you wish to select. Or you could press U for the raycast polygon tool, which allows you to simply click and drag over the polygons you want to select. The same methods are used for selecting edges. Using I, we can use the raycast edge tool to click and drag over edges that we want to select. Or, using E, the ordinary edge selection tool, we can draw a box that surrounds the edges we're interested in. And for points, we'll only use the T to select individual points or to select a group of points. There are also a few other tools that we can use while selecting components. Extract the window, and let's take a closer look. The lasso tool allows you to draw a custom shape to surround just those components you're interested in. The freeform tool works by only selecting those components which you intersect as you draw. You may notice it a bit tougher to intersect points rather than edges or polygons. Most of the time, we're going to be using the raycast selection tools. It's worth noting that with the raycast tool, you can only select components from the side of the object in which your normals are facing. If you turn it around, you can't select them from underneath. We'll discuss normals in depth later on in this section. Rectangle raycast. Let's use a sphere to illustrate this one. Go to Polygon Mesh, Sphere. In this case, you've tried a simple raycast with the Y, and the polygons in the front and the back of the sphere are selected. Instead, if I do a rectangle raycast, only the polygons facing the view will be selected. Hit Enter. Let's add a few more subdivisions, which will really increase the detail on our sphere. And let's try the Paint tool. This is very useful. Just click, select a component, and this is our selection brush. The shortcut is F11 on the keyboard. So we press U for polygon, then F11 for the paint. The left mouse button will select, the right mouse button deselects, and the middle mouse button will adjust our brush radius. So we can use the paint tool with a different component selection mode. If we press T for points, and then F11, we can work the same way with points with the paint tool. Let's get a grid again. Polygon mesh, grid. If I have a polygon selected, and I press the Alt key, I get an option of the selection loop. If we look down at our information bar, we can see we have the left mouse button for range, middle mouse button for loop, and the right mouse button for menu. If I do a range with the left mouse button, I select the range of polygons. So I click and then select the range of polygons. This way. If I do a middle click, I will get a loop selection. Even if the polygon is immediately adjacent or next to it, I will still get a loop selection. It works the same way with the edges. We can press the Alt and left click to select the range. We can do it this way or this other way. We can even do it diagonally or this way. And with the middle mouse button, we can get the complete loop. We'll try it with a sphere. Add some geometry. Select an edge. Alt and middle click, and you'll see we get the complete loop. With the left mouse button, we get only a selected range. I can use the control to do multiple selections. This tool is available if we select options. It is the select edge tool with corners or round corners. So we can go ahead and select this way from here to here, all the edges. So remember, left for range, middle for loop. I want to show you how to use the tweak tool, which will be really handy when modifying objects. Get a grid and add, say, 24 subdivisions. Go to Modify Component and select the Tweak Component tool. The shortcut is M. 3 small icons appear, and we'll go through them. The advantage of this tool is that a component is activated whenever I place my pointer on top of it, whether it be polygons, edges, or points. We can click and drag on an edge. The same with points and polygons. So let's take a closer look at the 3 icons. The first icon is called the manipulator tool. By default, it's activated. And when I select a component, the 3 color axes appear. The same for the edges and polygons. So I can click and drag on an axis, or click in the center to freely transform, or select a specific axis, like X, Y, or Z, or move it freely. If you want to go to rotate, with the right mouse button, we select the tool. Now we can rotate on the axis. The same for any component we select. Press M on the keyboard, and we rotate. The second icon, let's see, we'll turn off the first icon for now. Let's say you want to place a point in the center of the polygon. I'm going to select Translate and move the point. What happens is we're moving all around in 3D, so the movements will not be accurate because we're moving freely in X, Y, and Z positions. So if we select this second icon, which is a magnet, and we move points, we'll be restricted to the polygon's surface. This way, we can modify without affecting the actual geometry. We can align our edges this way. And now the points won't be floating around in a 3D space. The third option is a weld tool. What this means is that if I click and drag on a point, a snap will occur welding the points together. So we can do this, drag and merge points together. And this way we're merging 2 points together to one. Select edges in the loop. If I go to M to move, but I don't have the first option turned on, when I click on a component, my selection will be lost. So click on the manipulator option to turn it on, and we can now freely manipulate our selection. We can also rotate or scale. Right mouse button, select the scale, and we can scale. That's the tweak tool. Let's take a look at another modeling tool, which will be the proportional tool. Let's get a polygon mesh, grid, we'll subdivide it, and we can use the M to manipulate with the tweak tool, but we will select this, the proportional option. A circle appears showing the radius influence of the tool. So now if we click and drag, you'll see that we will modify the components inside that radius. This works the same for polygons, edges, and points. To adjust the radius of our tool, we click and hold the R key on the keyboard. And with the left mouse button, we click and drag the radius. We can make it smaller or bigger. This is very useful when we are modeling organic shapes. Get a smaller radius. If we turn off the proportional tool for a second and drag a point, we will only work on that point and the area immediately around it. If we click again, select the proportional, we will work with the influence radius. Let's get a new grid, subdivide it, and now let's explore a little more of this proportional tool. Right-click on the proportional button, and we get its property page. The first slider is the distance limit, which is the same as the radius. We can adjust it here using the slider. We have a fall-off, which is the decay. We'll make it a bit smaller. Or change to a lot of fall off, or something in the middle. And if we want the fall off to be a little more angular, like this, the proportional tool also works if we select components. Let's drag and select a couple of points with the proportional tool, and the surrounding points appear within the radius. If I press the R key, we can see the radius interactively. I can manipulate these components. By clicking here, I can revert the settings on the page and continue working. It works the same way with edges and the radius. I can make the fall off a little bigger and move. This window appears, clicking the right mouse button on the proportional tool. M with proportional. We can turn off proportional, and you'll see the difference. Let's talk about clusters. Primitive, model, body man. Let's change to a shaded view. A cluster is a group of elements that make up an object. They can be a group of points or polygons. This is very useful to organize our objects. We can group our objects in different clusters. We can have a cluster for the head, another for the hands, the torso, the feet, and so on. Also, it's going to be very useful to add specific materials to groups of polygons. If we open up our Object Explorer, go to Man, and when we create clusters, they'll be added inside this little file. We're going to leave the Explorer window open so we can check out what's happening. Now go ahead and with Y, select the head, and we'll come in here and unselect these unwanted polygons. Now that we have just the head selected, on the right side, down here, you can see we have the cluster button. Click on it, and under clusters, a polygon group appears. If we click on it and press F2, and you can change the name to whatever you'd like. I'm going to go ahead and do the same thing for the arms. First, we'll work with one arm, and then we'll add the second arm. So you can learn how to add clusters to a selection. Click Cluster, rename. Now if we want to add the second arm to the same cluster, select the polygons, Control-click the cluster we want to add, and a plus or minus sign appears next to the cluster. Click on the plus. Now when I select the arm cluster, a highlight appears to indicate what is inside that particular cluster. In this case, the head or the arms. If I want to select the components of that cluster, we can click with the right mouse button and select Components. Then I can delete the polygons. Undo, and we can get our head back. Now, for example, if we want to remove the hands from the arm cluster, select the hands, select the arms cluster, and click on the minus sign. Now the hands are no longer part of the arm. Let's start to look at some materials so we can get an idea of how to apply materials to these clusters. Get a sphere, polygon mesh, sphere. Control D to duplicate, move to the left. Now with these two spheres, we're going to practice some basic texturing. We can access materials from the model toolbar, but we're going to change to the render toolbar first. Go to Material, and you'll see we have different types of materials. Fong, Lambert, Blinn. In this case, choose the Fong. Let's change the color. The difference of the materials are the shading types. In this case, Fong has a specular here, and we can adjust the color of the specular as well. Now select the other sphere, select the material and anisotropic, and change the colors. This will just get us started on some materials. If I want to return to modify the material, select the object, go to Modify, and click Shader, and we can return to modify the material. The shaded views in OpenGL give us a pretty good representation of the final material. Press the Q on the keyboard, click and drag to make a render region, and the shaded view looks almost the same as the final render. Press Q again and click anywhere to close the window. Adjust the colors. I can also copy a color by clicking and dragging from the color box to another. Now, how do we work with clusters in this way? We always have a default material, which is this gray. Go ahead and add a material, a Phong. Let's put it a little red. And then select some polygons. Go to Material, Constant. In this case, we have a cluster created. If you explore the object, you can see the cluster in the Explorer. We can then go and rename the cluster. Select another range loop and select a material. An overlap happens here when we have a new cluster created over a previous cluster. In this case, we have three options. Yes, we will remove the overlap from the previous cluster. In this case, I'll select No, so the cluster is moved from the previous cluster, and change the color. If you explore it, you can see we have the original cluster. Select some components, move them around, and the color is applied to the second cluster. Select the components and move them around. In other words, the same polygon can exist in multiple clusters, but each polygon can only have one material applied to it. This way we can start adding materials to different parts of our model. Now let's talk about curves. If I go ahead and draw a curve, I can left click and begin to draw the curve. And this is a cubic curve. If I press M, I have the nodes, which I can modify, and these handles. And I can manipulate these. Now let's draw a Bezier curve. Now you'll see we have two handles per point. This way, depending on which button we press on the mouse, we'll get different results. The left mouse button, translate the handle. Middle mouse button to break the relationship. Middle mouse button to translate. If I want to restore the handle relationship, right mouse button, select to align forward, to align backward, or to align both. Or we can make the following segment linear. Or the previous segment linear. These are Bezier curves. If you go to Modify, Curves, we have the Tweak Curve command, which is the same as the M on the keyboard, which we have been using. In Handles, we have Inverse, Open, Close, or continue adding components, in this case, points. If we go to Curve, Add Point, we have the option to add points at the end. If I want to add points at the beginning, I would press the right mouse button to get the menu, and select where it says left mouse button to add at start, and we start adding at the beginning. Right mouse button, we can close the curve, and you can see there we got it closed. We can go to the curve, remove points with the Remove Points tool, and start deleting unwanted points. Or we can go to the knots and remove knots until we have the desired shape. So now that we've drawn our own curves, let's learn how to use those curves to create some more complex geometry. So let's get a primitive curve arc. And let's make the ending angle 180 degrees to get a full arc. Go to Edit, Duplicate. There's the Duplicate tool and the Duplicate Single, which is the same as Control D. And let's press Control D again, and you'll see our actions repeated. Both the object and the translation I made to it have been duplicated. Now go to Create, Polygon Mesh, Loft, and select the arcs, the right mouse button, and there we create a lofted model. Now we have the property page and the options. I'm going to close and return to those a little later. XSI keeps a modeling relationship between the curves and the loft. So if I select an arc, the second arc, and scale it, the resulting object will be modified. And we can continue to tweak these arcs. Let's select these two arcs, for example. Go to our front view. Select some points. Like this. X for scale. Go to global and scale it a bit. You can see the resulting object from the scale. As you can see, the divisions of the model depend on the arcs. So if we explore our polygon mesh and the loft operator, we can add subdivisions, as many as we want, which will make our object smoother. Go back to the arcs, delete the move components that we used. Delete. And we get our model. And now we can continue to modify the model. The object is still related to the arcs, so if I delete the arcs, the object's going to be deleted too. What we need to do is select the object and hit freeze. This way, if I select the arcs and delete them, we'll still have our final object. Let's do another one. Let's draw a curve. Get a circle. A little bit smaller. Let's create polygon mesh. Make a curve. Left click on the curve. And we get a new model. But this model lacks subdivisions. So let's go back and add some more subdivisions. We can then go back to the object and scale it, and it will still modify the resulting object. In this case, we use a curve to create our object. So if we select the curve, turn to our wireframe view, hit the M, we can go back and manipulate our curve. Move our components around. like so. Alright, I'm going to show you how to manage normals, which can really help keep your render times down. Let's start by getting a grid. We'll subdivide it a little bit and make it bigger. Now normals are directions in which the polygons are facing. In this case, the normals will be facing upwards. If we click on the little eye here and select normals, you'll see blue lines appear in each vertex. Normals are used as an optimization at rendering time. We can tell the renderer not to render the backside of the polygons. Now if I select and modify the object, see how the normals change, the way they're pointing out. In some cases, we need to invert the normals because we want to work on the inside of an object. So we'll go to Polygon Mesh, Invert Polygons. Alright, let's talk about how the way you select an object can affect its normals. Here I've arranged a series of closed circles in my scene. Once you have them placed, you can do a loft, select right, left, and we have inverted normals. We can either select the object and go to Polygon Mesh and invert the normals, or select the curve, curve inverse. These are our two options: invert the object or invert the curves. Now let's take a look at the polygon modeling tools. We'll get a primitive, curves, circle. Go to Create, Polygon Mesh, Extrude Along Axis, and turn to Shaded View. In this case, the normals are inverted. So let's go to Modify, Polygon Mesh, Invert Polygons. Now if our object here was to be a tunnel, we would leave the normals facing inward. In the property page, we have subdivisions for the geometry. These are from the circle. You are modifying the circle and the radius. We can also go and modify the U subdivisions and the V on the object. We have hide, unhide, which hides the curves we use to create the object, or generate automatic UVs, which you will see in the texturing steps later. The length, we still have a relationship between the curve and the object, so we can modify the shape, if we want to add a point to the curve, go to the curve, add point, and with the left button, we can add points in between. Then we can continue to edit our geometry within the curve. Now, for example, if I draw a curve, we select Original Curve and go to Polygon Mesh, Extrude Along Curve. We get a Pick Session, select the curve, close the window, and move these around. We have a similar page in which we can add geometry, subdivisions, form the curve, or the radius. We have a start and an ending position. As you can see, which can be animated. We can hide or unhide the curve. We can go and select the curve, change to wireframe, press M on your keyboard to tweak, and now we can freely modify our curve. And we can continue to work and tweak until we have the desired shape. Let's take a look at the Revolution tool. I've drawn a rough profile of a pillar using the curve tools. Just draw a profile. Now select the curve, Polygon Mesh, and select the revolution around axis. Lock the window. And in the property page, we have subdivisions, U, and in V. By default, they are applied per span, which means that they will be applied per point in a drawn curve. We can change it here to absolute, which will create an average between the end and the beginning. This is depending on the points, and it's an average between those outermost points. Since there's a modeling relation, we can continue to modify our profile. Zoom in and select your curve. In this case, the revolution object is inversed. We go to Polygon Mesh, invert polygons, and we'll continue working. Let's draw a vertical line. From here to here, and we'll use it as a revolution axis. So select the profile, go to Polygon Mesh, Revolution Around Curve, and select the curve. This enables us to modify the revolution around that axis. If we want to go back to the operator, go to the Explorer by pressing 8, Polygon Mesh, expand, and you'll have the revolution operator. We can single click on the icon or double click on the name, and we have all the profile information and the revolution information. Now if I select a profile and do a freeze M, when we explore the revolution operator, we'll have a cleaner interface. Now we can only see the information relevant to the revolution operator. Also, I can select a profile curve, go to Modify, Curve Inverse, and my revolution object will have the correct normals. If I select the profile again and go to Polygon Mesh, Revolution around Axis, we have 3 axes to choose from. Since we drew in the front perspective, the vertical axis would be the y-axis, so I want the revolution to rotate around the y-axis. We can also change the revolution axis, getting different results. This is in the x-axis, z-axis. So what it's doing is taking the profile and rotating it around the z-axis. We can mix the 2 axes, the x and the y, and it's similar to what we did with the revolution around curve. If you look at the bottom, you can see the inverse curve operator appears. Once we were happy with the revolution model, we could hide, or we can unhide, the curve profile, but the operator remains related to the profile curve. Or we could just delete, which would erase the operator, and the curve which we used to create it. And now we have a new element in our history stack. Now we're going to talk about the duplicate tool. In this case, with an object selected, go to Edit, look at the duplicate, let's extract the window. First, we have the duplicate tool. The shortcut is the D on the keyboard. With an object selected, wherever you press D on screen, we'll get a duplicate of the object. The duplicate single will make an exact replica of the object, size, position, everything. The shortcut for this is Control D. You can select a single object or multiple objects, hit Control D, and then we can move them around. Now let's get a polygon mesh sphere. If we duplicate it with Control D and move them, XSI remembers the transformation. If we do a Control D again, it will repeat the last operator. Control D, Control D. If, for example, we want to duplicate this sphere, but we also want to duplicate the movement to the front, we do the following. Just select another object, and then reselect the object we want. Now duplicate and move. This way the operator history is related, and we continue to duplicate the other objects. Control D, Control D. If we want to stop working with the options, go back to our D, duplicate options, transform, and here we have the operators that are being memorized. If I want to affect the scale, 0.5, 0.5, 0.5, when I duplicate, I will get those values. If we put a 0 here and we duplicate, we get the same value. 0, duplicate, and move. Sometimes this is very useful to select the list, duplicate, duplicate, and we get the same results down the road. Let's take a look at another duplicate option tool, which is the clone tool. In this case, the clone is single. Move it away. The clone tool makes an exact copy, but keeps a modeling relation. So if I modify the parent object, the same modifications will happen to the clone. But any modifications you make to the clone will not affect the original. And as you see, the operators for scale, rotation, and translation will not affect the clone, only if I modify the components. Select the face and delete it. If at some point I want to break the relationship, select the clone and click on the freeze sign, and the relationship is broken. Middle click on the primitive to get another sphere. Control D for duplicate. Select the sphere and go to the duplicate clone. This is with duplicate, and this is a clone. If I modify this object, only the clone will be affected, not the duplicate one. Let's look at another modeling tool, which is a loft. Sometimes it's called a skin. Get a primitive, circle, and duplicate it a couple of times. Now go to Create, Polygon Mesh, Loft. Select the object in a clockwise manner, and right-click. This will create a skin between the curves. And now we have a modeling relation between the curves and the loft or skin. Try taking these two curves and modify the points and continue to scope the model. We can also continue to add operators. In this case, we want to continue the loft. Select the last curve, duplicate it, and move. Now explore the created polygon mesh. With the operator selected, go to Edit, Operator, Add Input, and select our new curve. Our loft is extended to that circle. We also have another option in that menu. Let's leave it out for a second. With the loft operator selected, we have remove input, so we can remove this input, and then we can go back and add an input and add this one. So we remove this one from the relationship. We can also substitute an input. In this case, the circle is not used for the loft. So select the operator and the circle we want to substitute. Select the substitute input, and you get a pick session. Just select the circle you want to substitute, and the operator changes from this circle to this circle. If you want to add inputs, just select Add Input, and then select the curve you'd like to add. Now we have a modeling relationship again with this one and this one. Now let's practice using some of the tools we've discussed to create an object from scratch. First, get a cube and choose Create, Polygon Mesh, Subdivision, and delete the operator. Subdivision is a method for creating a high-resolution object from a lower-resolution object. There are several different subdivision methods in XSI. If you're interested in the theories behind them, you can check out the XSI documentation under Polygon Modeling. For now, we're going to begin to work with our subdivision using the tweak, proportional, and some other tools. and ultimately we'll form it into a futuristic helmet. So let's get started. Now we'll switch to our shaded view, and we want to work with only one half of the model. So select the polygons with the Y key and hit delete. At the end, we'll do a symmetry and recover the other side. Alright, let's add some detail. Go to Modify, Polygon Mesh, and we can start adding detail. We can connect these edges here, another one here. We can select an edge, subdivide it with split control, or evenly. Evenly would subdivide the edge by its center. And we can select here our number of subdivisions. Just 1 and 1. Connect from here to here. When I select the M tool, which is the Tweak Component tool, I get these three icons. Again, the first one is the Manipulation tool. The second is the Magnet, which is to move the component without deforming the geometry. In this case, I want to move it. I want to move it within the polygon. The other way, without the option. Will move freely and can deform the geometry. The third one is the Weld tool. If I want to join these points together, we just drag and select the points, and it will merge the points together. But let's hit undo for now. Now I want to connect this with an edge. I'm using the \/ key. If I want to give it a little bit more roundness, select the edge here, select the parallel edge loop, and it will subdivide evenly so I can start to work on the detail. Let's remove this snap. And we can start modifying more geometry. In this case, I want to take these polygons, duplicate, and scale without proportional. Click and move to the inside. And now I'm going to erase these polygons right here. And using my proportional tool, so I can get a more organic slope to my helmet, I'm just going to move these up and then make some more adjustments. This one, a little bit bigger. And modify from the inside. Now we can also select points and in Tools, get the Paint Selection mode without symmetry. This way I can select the points inside the Paint tool now I can go here and move them. And this is going to be the beginning of our helmet. So we'll set a border here, select the edge, part of the edge loop, in this case from here to here. We can use the control to make it snap to the center, M to move and adjust a little bit. We're going to try to preserve four-sided polygons and try to avoid these irregular polygons. So make a subdivision, and now we get four-sided polygons. Now continue to add edges to make it smoother. And pull this one out a little bit. If I select the magnet, I can move the point around without affecting the geometry. So select these inset polygons and delete them, forming the opening of our helmet. If I want to round this out a bit more, select this edge, split the edges evenly, and select the edge loop. Now we can adjust without the magnet. And just continue to modify. So we're going to continue on through here. We're going to add some more edges and keep rounding out the shape of the helmet. If we want to add a little detail here, we can select this edge and subdivide it to make a triangle. Then we can select this one, duplicate and scale a little bit less, duplicate and move to the insides, just to get a little detail. And if you get an irregular polygon, it's better to subdivide it this way. We can also subdivide here and get a little more detail. Now I can work with the symmetry. But as you see, all these points are not in the center. So select the points and scale it to 0 in the X. And the points will align themselves. Now go to Modify, Polygon Mesh, Symmetrize Polygons. And we get a symmetric object. Here I have the option to add a little offset. And this is the distance for weld. There's also an option for bridge, which means to add some polygons in between. In the case of our helmet here, it works pretty well. So let's scale it a little bit. That's good. And that's it. Now select the object, go to Create, Polygon Mesh, Subdivision. You'll see we've created a higher resolution model from our existing model. Let's hide the low resolution object, so we can just see our higher subdivision object. And now we can adjust our subdivision level. We also have different types of subdivision. These are actually different mathematical methods used to subdivide each polygon in our model. To finish with this model, we'll try to smooth the edges a little bit here. So select the object, go down to Deform, and Smooth. And it'll smooth out our edges. If we do too much smooth, we're going to start to lose a lot of detail. So let's do it a little bit less. Right about there. And more or less. And now we have our helmet. So to finish refining the model, we're going to add a symmetry map to tweak. Go to Property, Symmetry Map, and activate a symmetry and the Proportional tool. Now we can just go through and adjust our geometry this way to get more of the shape we're looking for. Holding R, we can adjust the radius. Like so. And just finish up the details. Make the radius a bit bigger to smooth out this border here. Same here. Just a little bit more radius. Modify a little bit. You know, it's very similar to sculpting with clay. Just kind of tweak it till you get it the way you like it. And here we have our finished helmet. Pretty cool. In the next few chapters, we're going to go into more detail on modeling and in texturing. So let's keep going.